Hi, my fellow friends. So we are from Chemical Product Design Group 7. We will be demonstrating how to use ICAS software to solve product design problem for Azeotrope. So for our case study, the problem given is to find all of the binary mixtures that form an azeotrope with ethanol at 1 atm, where the other compound is an acyclic compound having 300 to 400 temperature boiling point. So at the end of our session, we should be able to generate something like this in our ICAS software. So it will show the azeotrope form, the properties, and the miscibility of the azeotrope form. So this one is the main page of the ICAS software. So first we will set the title. So the title is binary azeotrope with ethanol. Totally miscible. So since the compound we want to generate is acyclic, so we will pick acyclic and generate isomers. As for the pre-selection, the selected group involved are acyclic compounds including hydrocarbons, aldehyde, acid, ether, and esters are considered using the basic set of group CH3, CH2, CH, C, CH3CO, CH2CO, CHO, CH3COO, CH2COO, HCOO, CH3O, CH2O, CHO, COOH, and COO. So here we're going to pick alcohol, ketones, aldehyde, acid, ester, and ethers. So we can scroll down. So here are the selected group. So we can cross-check with the selected group given from the case study, make sure they are the same.
Then we set maximum functional group and maximum same functional group up to 1. Take the perform database, then we can check the properties of the azeotrope from latest. Press the non-temperature dependent properties, right click, and we set the boiling point, which is from 300 to 400, and disable the go. Then we set.
Next, we got mixture properties. So tick at perform mixture calculation, and then since it's vapor liquid equivalent, we choose VLE, and then we set the condition the temperature at 350.5 while the pressure is at 1 bar. Then we want to form a low boiling homogeneous azeotrope with ethanol and 1,2-dimethoxyethane. So we need to select the 1,2-dimethoxyethane and ethanol. So select from database, and then we need to search by name, formula, or the CAS number. So first we search for ethanol, and then we click the ethanol and add it. So next we need to search for 1,2-dimethoxyethane, and then we press add, and then press OK. So next we need to set the mole fraction. In our case study, the ethanol is estimated at 0.71, while 1,2-dimethoxyethane is at 0.29.
Next, we will scroll up and choose azeotrope miscibility calculations. So here we have to perform azeotrope calculations and perform miscibility calculations. Then we want to form azeotrope, so we have to pick form azeotrope. Then we want to generate tables to show our data and miscibility. So we have to perform calculation in an interval, and then we choose totally miscible. Then mole fraction we will set 0 to 1 in 10 steps, and temperature we will set 300 to 400 in 4 steps.
So we can press run. As we can see, there are 5,614 molecules generated,
and only 20 matches the target properties constraint. So from the table, we can see the properties and miscibilities of the Azeotrope form, and we can press the arrow to see the Azeotrope involved. And then to check the properties, we can press the data bank. So we can see the name of the Azeotrope form, the case number, and the formula of the Azeotrope. And then we can see the other property in page 2 and also in a page 3. And we can also see the group description for the Azeotrope box. So that's all for our presentation. Thank you.